So in this video, I am continuing to go through an old final for trigonometry. I was having some technical difficulties while I was making the last video, so I stopped and I restarted this video. Hopefully things will now work out correctly. So this next problem that we're looking at says if cosine theta is equal to -5/13 and theta is between pi and 3 pi halves, find sine theta and tangent theta. So we don't know what angle cosine gives us back -5/13. So what we're going to do is we're going to create our triangle. And so we have a triangle here. And we have our angle theta. And so here, cosine theta, I know, is adjacent over a hypotenuse. So the adjacent side here is 5, and my hypotenuse is 13. So my opposite side, maybe let's just call it B for now. B is equal to, using the Pythagorean theorem, isolating B, we get B is equal to the square root of 13 squared minus 5 squared. So this is equal to the square root of 169 minus 25, which is equal to the square root of 144, which is 12. So now we have our triangle, we can evaluate our other trigonometric functions that they asked us. Be cognitive that our angle here, theta, our angle is between pi and 3 pi halves. So theta is contained in quadrant 3. So when I'm looking at sine theta, I know sine is negative in quadrant 3. So sine theta is equal to negative. And then looking at my triangle, sine is opposite over hypotenuse. So opposite of my angle theta in my triangle is 12, hypotenuse is 13. So sine theta is equal to -12/13. Tangent theta. No, tangent theta is opposite over adjacent, but in quadrant 3, tangent is positive. So opposite of my angle theta is 12, adjacent is 5. So the next example says, clearly sketch the graph of y equals -2 cosine of 1/3 x plus pi thirds. I'm going to change this problem a little bit. Let's put in a vertical shift in here too. So that, let's say it said +3. So in your exam, I might ask you some multiple different types of questions. I might ask you, what is the amplitude? So recall the amplitude, the only trigonometric functions that have amplitude are sine and cosine. And we find the amplitude by looking at the absolute value of our coefficient that's in front of sine or cosine. So our amplitude, usually denoted by A, is equal to the absolute value of -2. So A is equal to 2. I would ask you to find your period. So for my class, what I tended to do was I sandwiched our argument. So our argument here is that 1/3 x plus pi thirds between the one cycle that cosine would give us. The period of one cycle normally for cosine is between 0 and 2 pi. And so looking for the period, and this just helps us when it comes down to graphing these. 0 is less than or equal to 1/3 x plus pi thirds, which is less than or equal to 2 pi. So our goal is to get x by itself in between these two inequalities. So let's first subtract pi thirds on both sides of our equation. So doing so, I get that negative pi thirds is less than or equal to 1/3 x is less than or equal to, well, I need a common denominator there. So my 2 pi times 3/3 is 6 pi thirds minus my 1 pi thirds, which is going to give me back 5 pi thirds. I want that to be x. I don't want it to be 1/3 x. So I can clear my fraction by multiplying every single side of my inequality by 3. Doing that, I get that I have negative pi is less than or equal to x is less than or equal to 5 pi. So to find that distance between negative pi and 5 pi, which would give me my period, I'm looking at the larger value 5 pi minus my smaller value, which is negative pi. That gives me 5 pi plus pi, which is equal to 6 pi. So my period in this case is 6 pi. I may ask you what the phase shift is. Well, because we did this way, we can see that we are going to the left pi units. So graphing the following, I might ask you to give me your start point of one cycle of our period, the quarter point, the half point, the 3/4 point, and the end point. So doing what we had just done, we know that at the start, we're starting at negative pi. And we're ending at 5 pi. I want to get my halfway point. To get the midpoint, what we're going to do is we're going to take our start value plus our end value and divide that by 2. A lot of times we're dealing with fractions. And so if I was dealing with fractions, instead of thinking of it as dividing by 2, I would think of it as multiplying by 1/2. In this example, there's no fractions, but your example or your problem on the final may have fractions. So I have negative pi plus 5 pi is 4 pi. 4 pi times 1/2 is 2 pi. So I know my halfway value here is 2 pi. So to get my quarter value, I'm looking at starting at negative pi plus my halfway point, 2 pi, and dividing that by 2. So negative pi plus 2 pi is pi. Pi divided by 2 gives me back pi halves. My 3/4 point, so my start value for my 3/4 point to find the midpoint is 2 pi. Plus my end value that I'm trying to find the midpoint between, which is 5 pi divided by 2, is 7 pi halves. So if I have here, this is pi, negative pi. This is pi halves. This is 2 pi, 7 pi halves, and 5 pi. So in this example, I have a vertical shift. And so that vertical shift is telling me I'm taking my function and I'm shifting it up 3 units. And so I'm going to do a dotted line. And this is my midway line. And this is what I'm going to treat like what was my x-axis if I didn't have a vertical shift. I have a cosine function, so I am either going to start at the max or the min, depending on the value of the coefficient in front. The coefficient in front of cosine is negative, so I know I start at my min. Well, let's think about what is the maximum value I'm going to hit on my graph and what is the minimum value because of this vertical shift. Well, without that vertical shift, our amplitude was 2. And so my maximum would have been 2. But because of that vertical shift, it's now going to be 2 plus 2, which is 4. My minimum value before would have been, I'm sorry, I am adding, my vertical shift was 3. So it's 5. So my minimum value of this function would have been -2 without that vertical shift, plus 3. So my minimum value is going to be 1. It's off there. -2 plus 3 is 1. 2 plus 3 is 1. What's off is where I put my 5. Okay, so I'm starting at my minimum value at my start point of my period, which I said was -pi. This is the start of one of my cycles. At pi halves, I'm going to come up and I'm going to hit my midway line. At 2 pi, I'm going to hit my maximum value. At 7 pi, I'm going to come back down and hit my midway line. And at 5 pi, I'm going to hit my minimum value. So we got the graph of one period in here. I may ask you what the domain and range is. Well, the domain of this function, we don't have any trouble spots. Cosine, the domain is -infinity to infinity. The range, so the lowest value that we're hitting on this graph is 1, and the highest value we're hitting on this graph is 5. So our range falls between 1, including, to 5, and including. So I put this in interval notation, so bracket 1, 5. You could do that in inequality notation if it doesn't specify what I want. And so our range, our y value is 1 is less than or equal to y is less than or equal to 5. So you should be able to graph a trigonometric function. And you should be able to state the period. You should be able to state the phase shift. If it has an amplitude, the amplitude, you should be able to find some critical values to help you graph this, find the domain and the range. Notice that this had been, let's just look at it. Instead of cosine, let's say this was y was equal to -2 secant of this 1/3 x plus pi thirds plus 3. If that had been the case, I would have graphed my reciprocal function of secant, which is cosine. I would use that graph to help me find my secant graph. Where it was crossing the midway line, that is where our function is undefined. And so those are where our asymptotes were for our secant function in this case. And so to get the graph of secant, I would find where my minimum point was, and then I would have this kind of what looks like to me a downwards parabola. It's hugging my asymptotes. Maximum I'd have based off of that. It's what looks like to me an upward parabola. So what is in orange would have been the graph of my secant function, -2 secant of my argument, which is 1/3 x plus pi thirds, and then outside of the argument plus 3. So if I had asked you here, what is the domain, we need to be careful because there's values where this function is not defined. And so it's not defined where we have our asymptotes. So at theta cannot be, or x in our case, because we're using x. x cannot be pi halves. So let's look at that value, pi halves to 7 pi halves. So pi halves to 7 pi halves, that is 6 pi halves or 3 pi. So plus 3 pi k. And then our range in this case, well, my value is coming from negative infinity up to my min value of my cosine, which was 1, including, so bracket union, and then I'm starting here at 5, going to infinity. If I asked you for the amplitude, recall only our cosine and sine have amplitude, so that's not available there. Okay, so just extending that problem a little more to recall graphing a couple more different types of trigonometric functions. So for my class, I would worry more about cosine, sine, secant, and cosecant. But if you're taking another trigonometric class, you should be worried probably about tangent and cotangent also. So in the next example here, it says derive the 3 identities for cosine of 2 theta using the formula for cosine theta plus theta. So I have cosine theta plus theta. So I have a sum of 2 angles for cosine. So I recall that my sum of 2 angles for cosine is going to be cosine of the one angle times cosine of the next angle, opposite sine of what was in between, and then sine of the one angle times sine of the other angle. So in this case, this is cosine of theta, cosine of my other angle, which is also theta, opposite sine, which is minus, and then sine theta times sine theta. So this is equal to cosine squared theta minus sine squared theta. So there is one of my double angle formulas. To get my other 2 formulas, I'm going to use the Pythagorean identity, which says that cosine squared theta plus sine squared theta is equal to 1. And with that Pythagorean identity, I am going to either solve for sine squared theta in terms of cosine squared theta, or solve for cosine squared theta in terms of sine squared theta. So sine squared theta in this case is the same thing as 1 minus cosine squared theta. So if I use that fact and I do some substitution in here, I get that cosine 2 theta is equal to cosine squared theta minus, I need to be careful because there's more than one term here, so I need parentheses, minus what sine squared theta is, which above I said was 1 minus cosine squared theta. So let's distribute that negative sign. And I get that this is cosine squared theta minus 1 plus cosine squared theta. So I have 2 like terms in here, cosine squared theta plus cosine squared theta. So 1 plus 1 is 2. So this is 2 cosine squared theta minus 1. So here is another identity for the double angle of cosine. To get the next one, going back to that Pythagorean identity, let's solve for cosine squared theta. So subtracting sine squared theta on both sides, I get that is equal to 1 minus sine squared theta. So let's go do some substitution. So plugging in sine squared theta for cosine squared theta and using the first formula I found, I know that cosine of 2 theta is equal to cosine squared theta, which we just said is the same thing as 1 minus sine squared theta. Bringing down the next term, minus sine squared theta. So I have 1, and negative sine squared theta minus sine squared theta is minus 2 sine squared theta. So in here, I have my third identity for the double angle for cosine 2 theta. So in our next problem, it says prove each identity. So our first identity is cosine of x all over the quantity 1 plus sine x. And then plus another fraction. The numerator is 1 plus sine x, and that's all over the denominator of cosine x. We want to show that that's equal to 2 sine x. So recall, when you're working with an identity, you're only working on one side of your identity. You're not moving things back and forth to each side of your equal sign. Usually you're choosing the more complicated looking side to work with. And you're taking that more complicated looking side and working at that and manipulating it to look like the other side. So one of the ways to do this, if you have a fraction or multiple fractions, is to first get a common denominator. So I find that my least common denominator of 1 plus sine x, that quantity, and cosine x is the multiple of cosine x times 1 plus sine x. So I notice that that first fraction, in order to get my common denominator, I need to multiply that piece by cosine x over cosine x. So doing that, I get cosine squared x all over cosine x. I'm just going to write it as times the quantity 1 plus sine x. And then the second fraction, to get the common denominator, I am going to multiply that by 1 plus sine x all over 1 plus sine x. So if I multiply out 1 plus sine x times 1 plus sine x, so distributing that out and combining like terms, you should get back 1 plus 2 sine x plus sine squared x. So working with identities, you want to try to identify or recognize some of your identities, like cosine squared plus sine squared is 1. And so notice in our numerator, we have a cosine squared x plus a sine squared x. So I know that the sum of those is the same thing as 1. Plus, then I have this 1 plus 2 sine x all over my cosine x times the quantity 1 plus sine x. So I notice this 1 plus 1 here. To save time, I'm just going to rewrite that as 2 plus 2 sine x. So in my numerator, I can pull out a common factor of 2, which would give me 1 plus sine x, all over cosine x times the quantity 1 plus sine x. I notice that my factors, I have common factors in the numerator denominator of 1 plus sine x. So I'm left here with 2 over cosine x. Well, 1 over cosine x is secant x. So this is 2 secant x. In our next example that we're trying to prove, the identity that tangent theta is the same thing as sine of 2 theta all over the quantity of 1 plus cosine 2 theta. So my right-hand side is more difficult than my left-hand side. So I'm going to work on my right-hand side here. So let's rewrite sine of 2 theta using the double angle formula. I know sine of 2 theta is 2 sine theta cosine theta, all over 1 plus. So one of the formulas for cosine of 2 theta is 1 minus let me just think about that. So I'm going back, and we just derived this earlier problem in this final. Was that cosine 2 theta? This was equal to the cosine squared theta minus sine squared theta. So this was equal to sine squared theta is the same thing as 1 minus cosine squared theta. So this is equal to distributing my negative. This is equal to cosine squared theta plus cosine squared theta. So there's 2 of them. So I have 2 cosine squared theta minus 1. There it is. And so notice my 1 minus 1, those cancel. So I have 2 sine theta times cosine theta all over 2 cosine squared theta, which is the same thing as cosine theta times cosine theta. Notice we have a common factor of 1 cosine theta. I also have a common factor of 2. So we're left with our sine theta over cosine theta, which is the same thing as tangent theta. So in the next problem, we want to solve the equations, these trigonometric equations, and we want to solve for just the solutions between 0 and 2 pi. So looking at the first problem, part A says we want to solve this trigonometric equation cosine squared x plus cosine x equals 0. So this trigonometric function just has one trigonometric function, or this trigonometric equation just has one trigonometric function, and I can pull out what they have in common, that each term has a cosine x in common. So factoring that out, I get cosine x times the quantity cosine x plus 1 equals 0. So I can set each factor equal to 0. So cosine x is equal to 0, and I have cosine x plus 1 is equal to 0. So the values of x that give me cosine of that value gives me back 0. That would be when x is equal to pi halves and 3 pi halves. Cosine x plus 1 equals 0. So I'm looking at when is cosine of x equal to -1. So cosine x is equal to -1 when x is equal to pi. Our next trigonometric equation, cosine 2x plus sine x equals -2. So I would try to rewrite this in terms of just one trigonometric function. So we have 3 formulas for cosine of 2x. And one of them was 1 minus 2 sine squared x. So I'm going to go in and I'm going to replace cosine of 2x with that. So doing that, I get 1 minus 2 cosine, not cosine, sine squared x plus sine x equals -2. I notice this is quadratic, so I want to get everything to one side of the equation and set it equal to 0. I am going to move everything to the right just because I like to have positive coefficient in front of my squared term. That's just my preference. So adding 2 sine squared x to both sides, I get 2 sine squared x. Subtracting sine x on both sides, I get minus sine x. And then subtracting 1 on both sides, I get minus 3 equals 0. So then I'm going to try to factor this. So I notice I need to get a -3. So one of them is going to be a 1, one of them going to be a negative, or one is going to be a 3. So let's do +1 here and -1 here. Would that work? So not 1, it needs to be 3. So this is a -3 sine x, and a +2 sine x is a negative sine x, which I wanted. So I'm looking at when is 2 sine x minus 3 equal to 0, and when is sine x plus 1 equal to 0. So solving for this first equation, I would add 3 to both sides and divide by 2. So I'm looking at sine x equals 3/2. Our range of sine x has to fall between -1 and 1. So when I took the sine inverse of both sides, sine inverse of 3/2, that's falling out of my domain for the sine inverse function. So this is not possible. For sine x plus 1 equal to 0, this is when sine x is equal to -1. I know that sine x is equal to -1 when x is equal to 3π/2. So we have only one solution to this problem, which is 3π/2. So our next problem is sine of the argument, which is tangent inverse of the fraction 1/7, and then minus cosine inverse of the fraction of 5/6. If I could evaluate those inverse functions, I would, which I can't. And so I would create 2 separate triangles. I would say, okay, well, let A equal tangent inverse of 1/7. So I know tangent A is equal to 1/7. So creating my triangle A, a right triangle, I know tangent is opposite over adjacent. So opposite of A would be 1, adjacent of my angle A is 7, and now I need to find the hypotenuse. And the hypotenuse, call it C here, is equal to the square root of 1 squared plus 7 squared. So this is 1 plus 49, or the square root of 50, which breaks down, this is 2 times 25 underneath the radical, square root of 25 is 5, so I'm left with 5√2. I would create another triangle using cosine inverse of 5/6. So let's say B is equal to cosine inverse of 5/6. Taking the cosine of both sides, I get cosine of B is equal to cosine inverse, cosine of cosine inverse, which undoes itself, so equals 5/6. I know that cosine is adjacent, so creating my angle B, the adjacent of B is 5 over hypotenuse, which is 6. So my opposite side, let's call it B. B is equal to the square root of my hypotenuse squared, 6 squared, minus my adjacent side squared, 5 squared. So 36 minus 25, which is equal to the square root of 11. So let's rewrite what we started with and with our substitutions that we made. So this is the same thing as sine of angle A plus angle B. This is a sum of 2 angles for sine, so I can rewrite it. That's sine of the first angle A, cosine of the second angle B, same sign in between, plus sine of the second angle, which is B, cosine of the first angle, which is A. So now substituting in what sine of A is. Sine of A, looking at my triangle, is opposite, which is 1, all over the hypotenuse, which is 5√2, times cosine of B. Cosine of B we were given was 5/6, plus sine B. Sine B in here, looking at my triangle B, so opposite, which is √11, over hypotenuse, which is 6, times cosine of A. Cosine of A I'm looking at is 7, which is the adjacent side over the hypotenuse, which is 5√2. So I have a common, I do have a common denominator. My first numerator, 1 times 5 is 5, plus the second numerator, √11 times 7 is 7, square roots of 11, all over my common denominator, which is 5√2 times 6, or 30√2. So we don't like radicals in the denominator. Let's rationalize our denominator by multiplying by a fancy one of √2 over √2. And doing so, we get 5√2 plus, well, 7√11 times √2 is 7, square root of 22, all over square root of 2 times square root of 2 is 2. And that 2 times the 30 in front is 60. So this would be the exact form of that. The next problem says, write the complex number in standard form. So I have 4 cosine of 2 pi thirds plus I sine of 2 pi thirds. So we want to write this, I might state it in our class now, as rectangular form. So all we want to do here is evaluate each of our trigonometric functions at that angle. I know that 2 pi thirds, if I graph that, that's going to fall in the second quadrant, and my reference angle is pi thirds, which is 60 degrees. And so for all times, well, cosine of 2 pi thirds, it's negative because I'm in the second quadrant, and cosine of pi thirds, which is 1/2. Plus I sine of 2 pi thirds. Sine is positive in that second quadrant, reference angle pi thirds. And so sine of pi thirds is √3 over 2. So now let's just distribute our 4 to each term. And as I distribute that, I notice my 2 in my denominator is going to go into 4 twice. So we're going to be left with 2 times -1, or -2. Plus I, 4 times √3 over 2. 2 goes into 4 twice, so that gives me 2√3. Going in the opposite direction, we want to write our complex number in trigonometric form, which is the same thing as polar form, for the rectangular form of -√3 minus I. So if I graph that, I'm going to go over -√3 to the left, and I'm going to go down 1. So I'm falling here into the third quadrant. So we need to be careful here. We need to recall that we're in the third quadrant. We can create our triangle so we can figure out what our R value is, and we need to figure out what our theta value is. So creating a triangle, and my angle that I'm going to find first is my reference angle. I need to find my hypotenuse, which is our R value. So R is equal to the square root of √3 quantity squared plus 1 quantity squared. So underneath the radical, square root of 3 squared is 3, plus my 1 squared, which is 1. So 3 plus 1 is 4. So we have the square root of 4, which is 2. I can use tangent. So tangent of my reference angle is equal to the opposite side, which is 1, over the adjacent side, which is root 3. So I know that theta sub r, rationalizing my denominator, is tangent inverse of root 3 over 3. So I know that that is when theta is 30 degrees or pi 6. So that's my reference angle. To get down to that third quadrant, I would be adding pi, or 180 degrees, to whatever I was looking at, radians or degrees. So theta is either going to be 210 degrees, or pi plus pi 6 is 7 pi 6. So my polar form of that value is going to be r, which is 2, all times cosine of my angle. So let's just use radian, 7 pi 6, plus I sine of our angle, 7 pi 6. So the next problem says use de Moivre's theorem to compute the quantity negative root 2 plus I root 2. That quantity is raised to the 5th power. Express your answer in rectangular form. So let's first put this in polar form. And so we can do that by, again, graphing this. So I'm going to go over root 2 to the left, and I'm going to go up root 2. We can create a triangle. And I can find out what my R value is. So I know this is the square root of the one side squared, so root 2 squared, plus the other side squared, which is root 2 squared. So underneath the radical, I have root 2 squared is 2, plus the other root 2, which is squared, which is 2. So the square root of 4, which gives me back 2. So tangent of my reference angle is adjacent, opposite over adjacent, which is root 2 over root 2. So I'm looking at my reference angle is equal to tangent inverse. Root 2 over root 2 is 1. So I know that the value that gives me back 1 for my reference angle is pi 4ths. I'm in the second quadrant, so my value theta is pi minus pi 4ths, which is 3 pi 4ths. So this trigonometric function is the same thing as 2 all times cosine of my angle 3 pi 4ths plus I sine of 3 pi 4ths. And this whole thing is raised to the 5th power. So de Moivre's theorem says that we just take our R value and raise it to the 5th power, so 2 to the 5th, all times cosine of the angle that we had, 3 pi 4ths, times our exponent, which is 5. So we have 5 times 3 pi 4ths. Plus I sine of 5 times 3 pi 4ths. So 2 to the 5th, that's 32. This is cosine of 15 pi 4ths plus I sine of 15 pi 4ths. Okay, so we can rewrite this as equivalent angles that are between 0 and 2 pi. So 15 pi 4ths, so that is, let me just think about it over here. 15 pi 4ths, we can rewrite. Well, 4 goes into 15 4 times. So this is the same thing as 4 pi, plus we would be remainder of a pi 4ths. 4 pi, that gives me 2 complete revolutions plus a pi force. So this is equivalent to cosine of pi force plus I sine of pi force. It wanted this back in rectangular form. So we have 32 cosine of pi force is root 2 over 2 plus I sine of pi force, which is also root 2 over 2. Distributing our 32, 2 goes into 32 16 times. So I get 16 root 2 plus 16I root 2. So the next part of this final is a calculator portion. And so in this calculator portion, the first question says 2 points, P and Q, are on the opposite side of a river. And so there's a sketch there of your river and the 2 points on the one side of the river. From P to another point R on the same side is 300 feet. So we're given that this right here is 300 feet. If you formed a triangle between the 3 points, the angle R is 20 degrees. Let's form our triangle. That is 20 degrees. And the angle P is 120 degrees. I know the opposite side of my angle of my side of 300 because I have 2 angles of my triangle. I can get my third angle because I know the sum of all 3 angles is 180 degrees. So I have 180 degrees minus the 20 degrees plus the 120. So this is 180 degrees minus 140 degrees. So this gives me back 40 degrees. So angle Q is 40 degrees. So we want to compute the distance from P to Q. We want this distance here. Let's just call it X. I have a side and an angle opposite to that. This is not a right triangle, so I need to use one of my laws. I'm going to use, because I have the side and the angle opposite, that tells me to use law of sines. So I have 300 feet all over sine of the angle opposite 40 degrees is equal to X all over the sine of the angle opposite of X, which is 20 degrees. I can get what X is by multiplying sine of 20 degrees on both sides of my equation. So X is equal to 300 sine of 20 degrees all over sine of 40 degrees. So if I did not allow you to use a calculator on the test, you would leave it in this exact form. But with a calculator, let's see what we get. So plugging it into the calculator, we get that X is approximately 160 feet. And it did tell me where it wanted me to round. It wanted me to round to the nearest foot. Next example. So my, excuse me, my cat matrices sees another mouse. At the initial sighting, the mouse is due north at 50 feet. A moment later, the mouse has moved directly east at the, so that its bearing is north 35 degrees east. How far has the mouse traveled? Give both the exact value and the approximation. So I want to try, let's just call this X. I want to try to find X. So again, actually I have a right triangle in here. And so I want to find my opposite side, and I have my adjacent side to the angle of 35 degrees. So opposite and adjacent tells me to use tangent. So I have tangent of 35 degrees is equal to the opposite, which is x, all over the adjacent, which is 50. So I know that x is equal to 50 tangent of 35 degrees. So that's the exact form, and it's in terms of feet. Plugging it into the calculator, 50 tangent of 35, make sure your calculator is in terms of degrees in here. You get that that is approximately 35 feet. So the mouse has moved 35 feet. And the last problem on this old final states the following: 2 trains leave the railroad station at noon. The first train travels along the straight track at 90 miles per hour. The second train travels at 75 miles per hour along another straight track that makes an angle of 130 degrees with the first track. At what time are the trains 400 miles apart? Round your answer to the nearest minute. Okay, so let's write what we have. So we're trying to find what time it is. We know that distance is equal to rate times time. And we know the angle in between these two tracks is 130 degrees. And we have the distance of one of the train has gone, well, it's going 90 miles per hour. So distance equals rate times time. I'm going to want to find the time. So let's rewrite this as time is equal to distance over rate. I don't know what my distance is, but I know what my rate is. And actually, no, I know. So what do I do? Let's just keep it as distance equals rate times time for a second. So our distance here is our rate, which is 90 miles per hour times the time t. The other distance of our part of our triangle, we have a rate of 5 miles per hour, so 75 times t. And we know what this opposite side is of our angle, which is 400 miles. And it should have been miles. I was stating feet before for the sides of my triangles. So notice here I have two sides, unknowns, and an opposite side. And that two sides there, 90t and 75t, it's sandwiching a known angle. So that tells me I want to use law of cosines. So plugging this into the law of cosines, I know that 400 squared is equal to 90t squared plus 75t quantity squared minus 2 times the one side 90t times 75t cosine of the angle in between, which is 130 degrees. So 400 squared, 4 times 4 is 16, and then 4 zeros after is 160,000 is equal to 90t quantity squared, 90 times 90. That's 8,100t squared plus 75 squared gives us 5,625t squared minus 2 times 90, which is 180 times 75. That gives me 13,500. T times t is t squared, and times cosine of 130. So cosine of 130, I'm going to round in here, which is approximately negative 0.64. I'm not going to round though when I'm plugging this back into my calculator because I have the exact answer in here. I'm going to multiply that exact answer by that negative 13,500. Notice that all three of those terms on the right-hand side are like terms. They each have t squared in there. So multiplying that by 13,500 negative, and then summing 8,100 plus 5,625. So that gives me on the one side approximately 22,402.6. T squared is equal to 160,000. So again, I'm not gonna round when I plug it into the calculator. I'm going to keep it in that exact form. So I have 160,000 divided by that 22,402. Oops. Just going to keep that exact. And then it's t squared. So t squared, I need to take the square root of both sides of my answer, which was approximately 7.142. Again, I'm not going to round quite yet until the very end. So square root my answer. I get that t is approximately 2.672. So this is 2 hours. And that 0.672. I'm going to multiply that by 60 to get minutes, which is approximately 40 minutes. So that both trains are going to travel approximately 2 hours and 40 minutes until they get 400 miles apart. Okay, so hopefully that's helpful. Hopefully that tells you or shows you some of that or areas that you need to go back and review on.